perpendicular to the plane containing A and B, and it's such that AB and A cross B form a right-handed system.
So students, what is the right-handed system? The right-handed system is when you take your right hand and place your fingers like this with your index finger pointing to you, and this will be the x-axis, the y-axis, and the z-axis. So this would be the I, the J, and the K. So when the I is positive, when you turn it behind, which is facing you, the K is going to still be positive, but the J is going to be negative. And this works whenever you like. You can turn it everywhere, and then you will see if it's positive or negative.
The cross product between two vectors, A and B, is a vector quantity denoted by A cross B, having the following properties.
The magnitude of A cross B is the magnitude of A times the magnitude of B sine alpha, where alpha is smaller than A and B.
Exactly. And also, the vector A cross vector B is perpendicular to both A and B, which is perpendicular to the plane determined by the vector A and the vector B.
And lastly, the vectors A, B, and A cross B form a right-handed system, as we said earlier. So here, I'm going to show you the cross product in its component form.
So, let A equals to the bracket A1, A2, and A3, and B equals to the bracket B1, B2, and B3. So, Estelle, can you please show us how to do it?
Yes, sure. So here is its component form, which looks really complicated,
yes,
as we can see.
Super.
So we know that when vectors multiply each other, they cross each other out. So therefore, we get the simplified version, which is this. And after we get this, we can still continue to simplify everything to get the final version, which is A2B3 minus A3B2, A3B1 minus A1B3, and A1B2 minus A2B1.
Which is much simpler, isn't it?
Yes,
yeah.
So A cross B will be what we just learned just now in general.
So here's a question for you guys. The magnitude of two vectors A and B, and the magnitude of A equals to 4, and the magnitude of B equals to 6. And the angle between them is alpha equals to 120. So Estelle, could you please help us find the magnitude of the cross product of these vectors?
So to find the magnitude of the cross product of these vectors, first we will put the magnitude of A cross B will be 4 times 6 times sine of alpha, which is 120. So we will get 20.78.
Exactly. So here is the application of the formula that we showed us now. The magnitude of A multiplied the magnitude of B sine alpha, and this is how you use it.
So in order to help what we learned earlier, here's a small memory aid which is in the form of a diagram. So for our first column, we will put A1, A2, A3, A1, and A2. And for the next column, we will have B1, B2, B3, B1, and B2. So first, we are going to take A1 and B1 out of this picture by just crossing them out. So we are going to multiply A2 by B3 and then A3 by B2. So an easier way to remember this is to cross the top left one to the bottom right number, then the bottom left number to the top right number, and then subtract the lower number by the top number. This is going to be done 3 times for each column. So A2 B3 minus A3 B2, then A3 B1 minus A1 B3, A1 B2 minus A2 B1. And in the end, we will get a point, which is 3 of them to combine together.
So for this question, we're going to use the same way as what Estelle says now. So given two vectors, which is A and B, for A it's 0, negative 1, and 0, and for B it's 1, 1, 1. So we're going to do this exactly the same way as how Estelle did it just now. So we're going to cancel off the first two numbers, and then we're going to link this negative 1 here to the 1 here. And then minus off the 0 times 1 here. And you will get negative 1, because negative 1 minus 0 is negative 1. And you just do the same way as for the second one and the third one. and you will eventually find -1, 0, and 1. And this is how you do it.
So for the second question, the vector A is -I plus 2j and B is I minus 2j minus k. So how do we do this? In the earlier units, we've learned that unit vectors all have 1 as the number. So you just change all of them into their unit vectors, and after you do all the steps, you will get -2, -1, and 0 as the cross product of A and B.
So right now, we're going to do a proving question. So let's say you have a bracket of A minus B cross a bracket of A plus B equals to 2 bracket of A cross B. So how do you do it? Well, the first thing you're going to do is you have to find the one that is much more complicated and therefore change it into a simpler form. So in this question, we are going to use the left hand side. So A cross A plus A cross B minus B cross A and minus B cross B. So as we said just now, the properties of the vectors, if two vectors are the same, they can just eliminate itself. So in this case, A cross A, just get rid of it, and B cross B, just get rid of it. So what's left? Positive A cross B and negative B cross A. So in this case, we'll have A cross B plus A cross B. So why negative B cross A can become A cross B? Well, in this case, you can always switch the vectors around and you will get a positive A cross B. So in this case, you will get a 2A cross B. That is how you could do it, students. Alright, students. So right now, we're gonna do a unit vector questions. So firstly, you have to understand what is the formula of unit vector. So A cross B is divided by the magnitude of A cross B, and you will get a unit vector, which is right here. Alright, students. So right now, we will learn how to apply the formula into a question. So in here, A cross B equals to -1, 1 and -1. And the magnitude of it is 3. So the unit vector is A cross B divided by the magnitude of A cross B. And you will get -3 over 3, positive 3 over 3, and also -3 over 3. So this concludes our lesson.
Thank you very much for your attention.
We hope that you benefit from this.
And if you need any extra help, you can refer to our websites for practice and quizzes and more.
Exactly. So
Thank you
very
much.
much.